Hello, everyone. My name is Melissa Sussman. I'm the lead technical evangelist with Sumo Logic, and we're going to go through a bit of a Kubernetes demo. We're going to go into monitoring, troubleshooting, and securing your Kubernetes clusters. So to dive into some of what makes our solution a bit different from others, Kubernetes and microservices often introduce monitoring challenges in traditional monitoring tools due to things like the ephemerality across nodes, containers, and pods. Traditional monitoring tools, of course, make it difficult to pinpoint the exact combination of a pod and a node that are having a particular issue, and then drill into associated container logs to identify the root cause of said issue. So essentially, there are more things to monitor. Everything is ephemeral, and the workflow is spread across a bunch of different tools. Sumo Logic offers the ability to view your Kubernetes logs, metrics, and events in various hierarchies, allowing you to view your cluster in the lens of your choice. For example, we can use native Kubernetes metadata like namespace to visualize the performance of all pods associated with a particular namespace. So to give an example of what that might look like, here we have sort of what our Explorer view looks like. And on the left-hand side, you can see a variety of different namespaces as well as clusters. So let me get back to the slides. But before we delve into basically how we can help with the troubleshooting process, let's take a step back and then talk about how we collect logs, metrics, and events from a Kubernetes environment. So data collection with Sumo. So we collect logs, metrics, and events and security data using Fluent D, Prometheus, and Falco. All of these are open source data collectors maintained by the Cloud Native Computing Foundation. We're utilizing open source tooling for collection and data enrichment. And that's quite ideal given that these collectors receive a lot of community support and typically have integrations for any type of data that you might want to collect. So as we look at, for example, enrichment, from here we funnel everything through a centralized Fluent D pipeline for metadata enrichment. Not only do we tag the container, pod, node, and cluster, but we also identify the service and deployment for each entry. Kubernetes is rich with metadata, right, such as pods, labels, and namespaces. And the metadata are descriptors of these Kubernetes identities or entities and how they relate to one another. However, each log, metric, and event doesn't expose all of this metadata on its own. The purpose of our enrichment pipeline is to ensure that for every log, metric, and event, you know what container it's from, what pod that container is in, and what pod the labels are associated with, as well as the node it is on, what namespace it's running in, and what cluster it's running on. So with metrics serving as essentially the smoke detector and logs enabling us to drill down to a variety of different root causes, we can better identify and unify these data sources around a common metadata language, which enables us to easily correlate these signals. We can then also easily pivot from the metrics data about a cluster to the events data about a cluster, and then to the logs data about an application. So let's talk a little bit about collection. So all of this setup is basically done with a single Helm chart command. It can be as easy as like Helm install Sumo Logic. You give us an access key and ID, and we use that to create the collector that sources in Sumo Logic. And the Helm chart will configure and deploy FluentBit, Fluent D, Prometheus, and Falco. Then the data comes over to Sumo. So let's talk a little bit about each piece of the collection pipeline and how that essentially works. So for logs, for the log collection, we use FluentBit daemon set that runs on every node in the Kubernetes cluster. This will gather the logs and then ship them to Sumo Logic. For metric collection, we integrate with Prometheus, which is the de facto choice for monitoring any Kubernetes cluster. The main strength of Prometheus is that it has auto recovery, which works for pre-instrumented things in Kubernetes, along with any custom instrumentation that you may have implemented within your applications, right? Prometheus, because of this auto discovery, the Explorer view in Sumo that I showed a little bit of stays up to date with the live state of your environment. It learns new components, and the Explorer updates as the data streams into Sumo logic. However, Prometheus has a couple of weaknesses. The first would be scalability. So as your deployment grows and you end up with multiple Prometheus instances, this creates data silos, making the process of getting aggregate cross namespace visibility a real challenge. The second is it was never built for a long-term retention. However, by using Sumo logic for the metrics backend, we solve both of these problems. You can also, send all of your data to Sumo for long-term retention and get a single unified view of your entire cluster. Lastly, I'd like to talk about event collection. So for the events, we developed a new FluentD plugin that runs as a deployment. All events go into the API server. So the plugin essentially watches on the API server, and as new events are detected, those are shipped over to Sumo. With security event collection, so that's sort of similar to what we would be doing with like logs and metrics collection. There's a wealth of tools available to help provide container level Kubernetes security visibility. So these tools can also provide insight into behavioral activity to detect anomalous activity and security events, as well as provide insight into compliance and audit events. So our stock Kubernetes app includes an integration with Falco, an open source tool that detects anomalous activity and security events. Once deployed, Falco uses a kernel module, user space libraries, and Kubernetes audit events to watch for any security events matching one of the conditions defined in the Falco rule file. Notifications are issued for matching events and collected with FluentBit, just like with logs. So here we have some of our partner apps for security. We have Twistlock, StackRox, Aqua, and JFrog X-Ray. So we've partnered with a handful of other security companies and products to provide additional security insights into your Kubernetes environment. Each integration is supported by a Sumo Logic app built with our partners. So after we have the logs, metrics, and events from Kubernetes and Sumo, the next step is visualizing the data to give you additional insights. So one of the things we're doing here is looking at the infrastructure view versus the service view. And this kind of gives us an idea of what traditional monitoring tools typically use, and essentially what some of their problems might be versus what you might use in a more modern monitoring tool. Say that 3 times fast, geez. So first, they typically look at applications from a hardware or server-centric perspective. This makes sense for legacy solutions where the underlying infrastructure would often stay the same for months or even years, but this is no longer the case. Second, most solutions only provide visibility into a piece of Kubernetes, of that Kubernetes environment. Admins are forced to navigate between tools for logs, metrics, events, and security threats to build a real-time picture of application health. Third, the data is fragmented. A metric might be tagged with the pod and cluster it was associated from, while a log might be labeled using a different naming convention. The metadata enrichment process must be streamlined and centralized to gain consistent tagging and therefore correlation. This can make it near impossible to connect the dots between metrics on a node to logs from a pod in that node. So the reality is that pods, nodes, and even clusters can all be destroyed and rebuilt with ease, right? Effectively monitoring what is running on Kubernetes means to monitor at the application level, focusing on service and deployment abstractions. Understanding what is happening from a service and deployment perspective is critical to understanding the overall health of your application and, by extension, the customer experience. So monitoring solutions should align with the way Kubernetes is organized, as opposed to trying to fit Kubernetes into our legacy modes. So in about a second, I'm going to switch to the Explorer view, and then we can take a look at how this all kind of works. So let's take a look at the demo environment, as that's what the people want. So with Kubernetes, there's always some kind of mental model or hierarchy or typology that relates component A to component B to component C. Sumo allows you to look at your environment through these different lenses. Also, as mentioned previously, the underlying data that's generating these dashboards are logs and metrics. So we automatically build the Explore section on the left-hand side of the screen. So you can see all the clusters that have been instrumented with Sumo Logic's collection. In this case, we're looking at 4 clusters in the namespace view. So for example, perhaps I want to see things in the namespace view where I see a list of clusters, and then I can drill into see each of the namespaces and pods that are in that namespace, then the containers within those pods. So as I look at each cluster, let's say I select this Travelogic cluster, then I can take a look at any of these particular namespaces. Just going to select something random. Okay, so perhaps, I want to see things in a node view as well. So if I also wanted to do something like, instead of looking at the namespace overview, I instead wanted to look at things from a node view. I can then, expand different clusters, click on a node, and then click on a particular pod. In that case, if I wanted to look at the Explore by view and then switch it up, I can. So we're going to do that. All right. So now we're looking at the same Travelogic info, but now we're looking at it at a different level. Additionally, like on these dashboards, you can see there's another interesting component of the Explorer view. It's where you can not only easily visualize these hierarchies, you can essentially navigate and look at any of this useful information. Up top, I get to see resource usage statistics at a quick glance, errors by namespace, and security rules that in this case would have been triggered by Falco. Scrolling down, I can see also the pods that are running in the clusters and namespace statistics. Under the memory requests versus limits versus usage by namespace, I can also see actual resource usage versus CPU and memory usage requests, right? Down here, we're looking at a variety of different dashboards. It depends on what you're actually looking for. But there may be more than one dashboard that makes sense for your particular project. So for example, perhaps I want to see a more high-level view of each cluster. So here we are switching it up to look at the Kubernetes Cluster Explorer. In this case, we're looking at a high-level visualization of things like node resource usage across each node. And again, that let's say, relative memory usage by pod. So you can kind of see a variety of different, dashboards that you might want to take a look at. There's also this where you can actually look at the CPU pod details by node. If anybody wanted to look at like something very particular, if they saw, a particular IP address that they wanted to, I guess, drill down to, or if they wanted to particularly look at any individual node. It's kind of an interesting view. You can also look at all the logs within each of these nodes and error logs, error signatures, and then of course like recommended dashboards that the system might tell you to take a look at if you wanted to look at, let's say, a different view. All right, now that we have explored the Explorer view, we can take a look at, creating custom dashboards. So let's go through that as an example. First, we hit New, and then we go to Dashboard. So here we can see a variety of different panels we can do. So for example, we could do categorical, single value, map, text, honeycomb, traceless, service map, and of course, time series. So for now, we're going to just hit Add Panel, and then we're going to focus on time series. So this is where our new metrics query builder makes it pretty intuitive to find the data that you're looking for. For example, I know that the metrics I'm looking for are related to the travel logic cluster. So here's where I can start potentially typing in some like specific metric names. So for example, I know that it has to do with the travel logic cluster, and I know that the metric I'm looking for has something to do with memory, but I don't exactly remember what it's called. So we're just going to start with typing in container memory usage bytes, actually, so we want to look for here. And then in the get metric section, or in the filter section, rather, this is where we can actually start to filter by our travel logic cluster name. So this is where we'll actually type in cluster, and then we're going to look for, oh, here it is, prod01.travellogic.info, because that was what we were looking at previously in our Explorer view, right? And the goal, of course, is to come up with our own dashboards that come up in this view. So looking at this guy, we're going to go back to here, and then we're going to select cluster, and then this guy. All right, the last step is to try to aggregate this information. So let's do a search. And let's look at the preview table. So this is basically where we can also start looking at adding to the dashboard, or adding to dashboard, and then adding operator. We want to essentially look at the options here. You can look at advanced mode if you want to. Right now we're in basic mode. We can potentially add a monitor, so we can add additional like parameters as well. And then the ability to duplicate a query so that you can essentially have a secondary query, like this is A, it would give you a B, and then it would essentially, if you wanted to do a different preview table or a different chart. So this is where we're going to hit add operator, and then we want to choose average. And then this is where we want to, again, we want to select container. Next to by. And then finally, the query should basically appear as follows. We can then do this query search again, and it'll update the preview table, and it should also update our chart. And this is basically what our chart ends up looking like. So this is where we look at, let's say, the panel settings. This is where we can see the display. If we wanted to go to the general settings, we could go there. We can look at essentially our axes. We can start actually looking at how we want to display our chart. And then, of course, a legend, which will tell us, essentially what our metrics, how our metrics align. JSON file, if you need a JSON file for some reason. Anywho, we're going to go to the general settings up top, and we're going to name this thing. Since right now we're looking at average container memory usage, that's what we can call it. So let's just call it that. And we can increase text size a little bit so more people can see. I don't know. There we are. description. So this is where we can basically say, this is our test chart for usage for container. And yeah, this is where also if we wanted to make any additional changes here, like we wanted to look at the display and do something interesting, do different types of charts, we could do column chart, bar chart. I like line chart for this one best, but different options here, depending on how you want the data to be shown. And then for this second section, you can kind of go ahead and pick a different color chart if that suits you. Well, maybe we don't want this because the yellow and the green and the other green are pretty close together, but depending on what color you want, you can change the color palette. And then you then can add it to the dashboard and you click the add to dashboard button. That's the final step to create a stack link so that our custom dashboard shows up in the Explorer view. And to do that, essentially, you then select the options and create stack linking. So let's add to dashboard. All right, and this is what it's going to look like. So here we are looking at the dashboard that we just created. This is basically where, since I had already created something like this before, typically you would click on this and then you would add stack linking, but I had already done some stack linking previously. So what you would see is you'd have to select a domain. In this case, we're looking at Kubernetes. And then you would have to select entity type. In this case, we are looking at clusters. And then here is the entity name that we care about, the thing that we want to essentially tie back to, again, our Explore view. So that name you basically want to check again with like the view that you have over here. It's prado1.travellogic.info. Okay, cool. Now that we have double checked all of that, essentially you can look at the different views here. And this is where you can start to select your personal dashboard. So I believe the one we just created is actually this one, but regardless, I've created probably a few duplicates, honestly. So this is basically what it would look like once you're selecting it within the Explorer view. And essentially, I hope this helps with figuring out how to do your own custom dashboards. That's really like the strength of doing all of this within Sumo Logic. You can essentially create whatever dashboards you want, and then quickly use our built-in analytics platform to look at it in whatever sort of display you want. So on this last part, I'd like to quickly go over some of the built-in analytics capabilities. So let me just switch over to the namespace view. So we're in the node view, so we're in the namespace. Then we're going to go back into this prod travel logic. And then basically, we're just going to take a look at some of the dashboard analytics here. Here we can kind of see some of the security issues that are triggered. We can also make this a little bigger to make it more clear. So here you get to see some of the security rules that get triggered and essentially what some of the issues might be. Here you also can see the cluster view, and then essentially we can drill down into some particular problems. So we're looking at our travel logic cluster, which is a production application that our sales engineers often use to demonstrate the power of our capabilities. In this cluster view to the right, in prod login, we can see I notice a couple of things going on. So first, under errors by namespace, I see that the prod login namespace is having errors. And then if we, essentially take a look and then look into this a bit further, we can see there are these pods indicated in red in the prod log and namespace. And for this demo, we're going to focus on this one carbon black pod just to see what kinds of indications we can get as to what is going wrong here. So in the left navigation, we're just going to look at the prod log and namespace, and then we're going to just click into this carbon black pod just to see, you know, what could possibly be going on, what might be some possible issues. Essentially, after we click on that section, we're taken to this like namespace overview dashboard. Looking at the errors by pods, you know, we can essentially try to determine what some of those errors may be. Additionally, we can see that the pod state here indicates that it regularly gets terminated. And the reason says that it's OOM killed. So we might want to be thinking about why that might be. And essentially, in the pod view, we can basically try to determine, you know, things like percentage memory limit, perhaps try to get to an understanding as to like why it keeps shutting down and then coming back. We can also take a look at, you know, any particular events in the events panel. And we can see that it's, you know, back off, restarting failed container. Essentially, we can kind of come to an understanding that when a host comes under, you know, some amount of memory pressure, the kernel might elect to kill off processes. If a process is using more memory than its limit, it then moves toward the top of the list of potential victims, right? So the idea here is that Kubernetes the Kubernetes system is going to pack as much stuff onto a node as possible. And memory pressure on those hosts is not uncommon. So if your container is using too much memory, it's likely to be like killed. If it is killed, then Docker will be notified by the kernel, and then Kubernetes will find out from Docker, and depending on those settings, may then try to restart the pod. In this case, we can see that it's had, you know, several times that it's tried to restart it. And then also, we can see, you know, scrolling down a bit further, let's see what else we can find down here. So here we see memory usage versus limits versus requests. We can see that there's a couple of spikes here. So, you know, if we hover over the spikes in this panel, we can basically see that the reason the container is terminated definitely had to do with the like working memory set bytes. And let's see if we scroll down further, do we find anything else? Do we look at any other interesting things? Terminated containers by reason. Here, again, it's demonstrating that it was killed, I suppose, which isn't a surprise. The bottom line here is generally that it should be relatively simple to identify and troubleshoot issues like these here. Let me know if there are any questions at the end of this demo.